Good afternoon, mathematicians. Tonight we're going to be using real-world problems involving multiplication of whole numbers, mixed numbers, dealing with fractions to solve some problems. Here's a problem. Jane baked some biscuits. She keeps 3/7 of the biscuits in a red container, 5/8 of the remainder in a green container, and the rest in a blue container. There are 21 more biscuits in the red container than in the blue container. How many biscuits did Jane bake? Whew! Let's pause for a second. We want to go back. There's so much information in this problem. I think it would be super helpful to annotate and figure out how can we break this problem down into smaller steps and take it little by little. So the first sentence, Jane bakes some biscuits. Okay, great. There's nothing in that problem I want to annotate. We know that she's baking biscuits. She keeps 3/7 in a red container. So I'm going to know right away that 3/7 in the red container, that's important. And the next part says that she kept 5/8 of the remainder in a green container. So that word remainder, I'm going to put a box around it. It's so important. It's not 5/8 of 3/7, it's 5/8 of the rest. And then she even says she puts the rest, so even whatever, so maybe the other part, in a blue container. Okay, and while it's good to know that there were 21 more biscuits in red than in blue, that seems like a second part of the problem. I'm not going to play around with that yet. I'm going to wait and just deal with the first part of this problem first. So here's what we know. She keeps 3/7 in a red container. So what I'm going to draw first is I'm going to draw a bar and divide it into sevenths. That's my first fraction. So 1, 2, 3, 4, 5, 6. So when I do 6 bars, that means I have sevenths. And 3 of these sevenths are in the red container. So what I want you guys to get really good at is not only labeling with the numbers, but also labeling with words. So 3/7 are in a red container. We should be writing both. And even if you want to, you could put an R above each of these to show that they're in the red container. Okay, let's look at the next sentence. It says that 5/8 of the remainder. So again, you're just focusing on the boxes that we haven't touched yet. So do we have eighths as a remainder? 1, 2, 3, 4. We only have fourths. I bet you know what to do. We're going to divide every box in half. But guess what? We can't just divide the remainders in half. In order for every denominator to be the same, we need to divide all of the boxes in half. So what we know now is not only were these 3/7, how many do we have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We actually have 14ths now, which makes sense since we divided each box in half. And red now no longer just takes up 3 boxes. It's actually 6. So yes, 3/7, 6/14, that's how many biscuits are in the red container. Well, we know that 5/8, so now we have eighths, 1, 2, 3, 4, 5. So these 5 are in the green container. I'm going to put a G for green, but hold on. Are these 5/8? 1, 2, 3, 4, 5. We know that there's 5, but the denominator is not 8. There's not 8 in the whole bar. There's 14 boxes in the whole bar. So there's 5/14 that were in the green container. Okay, and the remainder, the rest were in blue. The blue container. So that's only 1, 2, 3. That's 3/14 that were in the blue container. Okay, so that's part 1. Now that I'm reading part 2, if I know there were 21 more biscuits in red than in blue, this is going to make me want to draw a different type of bar model. I might do something like this. If I know the word more, less, fewer, that to me is showing a comparison. And I want to draw a bar model where I can compare. So I'm going to do a vertical one where each container has its own bar. And how am I going to know what to draw? Well, I know that red had 6 boxes. So I'm going to do 1, 2, 3, 4, 5, 6, and we try and draw them the same size. Green had 5 boxes. 1, 2, 3, 4, 5. And blue had 3 boxes. 1, 2, 3. What information do I know from the problem? There are 21 more biscuits in red than in blue. So here's my stick of difference, and I show that the difference between the red container and the blue container is 21. Well, let me look at that. Red had 6 boxes. Blue had 3 boxes. That means from here to here, the difference between red and blue is 21. Does everyone see that those 3 boxes are equal to 21 since the difference between red and blue was 21? So let's just double check. Here's a red and here's a blue. Those are the same. Red and blue, those are the same. Red and blue, those are the same. So that means anything after that to the end is 21. Well, let's look at that. We have 3 bars that are equal to 21. What is each bar equal to? 21 divided by 3. Every bar is equal to 7. They were all the same size. All right, your homework is to answer this question. How many biscuits did Jane bake? Try and figure it out now. See you tomorrow.